This is your para. Two molecules will dimerize to form a single molecule. That's why this will have this will be more stable. That's why it is also measured. And since it is more stable, that's why the boiling point is more, and here the boiling point is lesser. And you can write it. This will be more volatile. It will be easily converted into vapor. So this will be more volatile, and this will be less volatile. So you already have studied this in the previous class. That is. So can I move to the next part? If anyone have any doubt, please ask me. Shrit, Priya, we just started electrophilic substitution reaction, chemical reaction of phenol.
Okay, sir.
Okay. Krishna, can I change the slide?
Yes, sir.
Okay, if anyone writing, please do let me know. Okay. Now, if you are going to treat this phenol with concentrated HNO3, if you are going to treat this phenol with concentrated HNO3, then the amount of NO2 plus coming out from here will be more, and in a single phenol, NO2 will be added at 3 places: ortho, para, and again ortho. And this has a IUPAC name 2,4,6 trinitrophenol, trinitrophenol, which has a common name which is quite famous, that is picric acid. This is your picric acid. So if you are going to treat a phenol with a dilute HNO3, you will get two products, that is ortho and para nitrophenol. And if you are going to treat this with concentrated HNO3, you will be getting picric acid. You will be getting picric acid. Can I change the slide? The next electrophilic substitution reaction is bromination or halogenation. You can call it halogenation. This is your halogenation. That means we are going to add halogen. And since we are doing for halogenation, we need to react this with X2 or X2 in the presence of carbon disulfide, or either you can take chloroform or haloform. Either you can take haloform. Now I'm going to show you the reaction. If you are going to react this phenol with Br2 in the presence of CS2 or chloroform, you can write, at low temperature, then there will be generation. With the help of this, there will be generation of an electrophile, that is Br plus, and this Br plus will be added at ortho and at para as well. This will be the major product and this will be the minor product. You just need to take care of the reaction Br2 in the presence of CS2 or CSCl3. Then it will generate an electrophile Br plus, and this will be attacking at ortho or para, because the negative charge or more electron density is only at ortho and para, because this is your plus M. And I already told you this plus M is either ortho or para directing. This plus M is ortho and para directing. So please take care of this. And if you are going to react this phenol with bromine water, that means 3Br2 in the presence of water, then you can see we will get this compound. OH will be here, bromine at ortho, bromine at para, and again bromine at ortho. So you can write a name of this 2, 4, 6 tribromophenol. Tribromophenol. So this is what halogenation, we call it halogenation. Marita, you had sent 2 questions today, right?
Yes, sir.
Okay, we will discuss after the class.
Okay,
So this
sir.
is halogenation electrophilic substitution reaction. Basically, there will be generation of an electrophile of halogen, and this is how we do generate electrophile for halogenation. Now the next reaction is Kolbe's reaction, that you already know. Kolbe's reaction. It is a name reaction. You just need to go with the step. What we do in Kolbe's reaction, this is your phenol. Since we are studying the chemical reaction of phenol, so concentrate here. We need to react this with NaOH, and this reaction we already have done in alcohol. When phenol or alcohol react with base, then there will be the formation of salt plus water. With the phenol we get sodium phenoxide. This hydrogen will be replaced by Na. And after getting sodium phenoxide, you are going to react this with CO2, carbon dioxide, followed by acidification. Then with the help of this, you will be getting OH as it is, and then COH, COOH. And this is your salicylic acid. Salicylic acid. Basically, when you are going to react an alcohol with carbon dioxide in the presence of acid, then you will be getting with the carbon dioxide, you will be getting carboxylic acid. So this is what we get. Its common name is 2-hydroxy benzoic acid. Its common name is 2-hydroxy benzoic acid. So this is the Kolbe's electrolysis. After this reaction, we have the most important chemical reaction, name reaction of this chapter, that is Rimmer-Tiemann reaction. Rimmer-Tiemann reaction. So this is your Rimmer-Tiemann reaction. And what we do in this, we are going to treat this phenol with chloroform in the presence of aqueous NaOH. Chloroform, CHCl3. Chloroform in the presence of aqueous NaOH. Then we will be getting an intermediate that is like this. This is your phenol, O negative, Na positive, phenoxide ion, and then CHCl2. And this is your intermediate. After this, you are going to treat again this with NaOH, that is base. Then you will be getting, this will be oxidized to aldehyde directly, and this will be as it is. This will be oxidized to aldehyde, and after getting this, you are going to treat this with acid, and you will be getting OH and CHO. And this has a name, common name, that is, the previous one was salicylic acid, and now this is salicylaldehyde. Salicylaldehyde. Now I'm gonna explain the mechanism a little bit. First of all, in reverse reaction, in all the mechanism, either there will be the formation of carbocation free radical or there will be formation of an intermediate, and here the intermediate form will be carbene. Carbene. Always remember there has been question that has been asked about this. In reverse reaction or in the formation of salicyl aldehyde, what is the intermediate? So the intermediate here is carbene. I'm going to show you how this CHCl2 become aldehyde. So I'm going to write this. As you know, this was your phenol, which is converted into phenoxide ion, and here it is CHCl2. So I'm going to write it CHCl and Cl. When you are going to dip it in NaOH, that is sodium hydroxide, this will be oxidized into hydroxyl group. This will be basically replaced with OH group, OH, and here it will be OH. And always remember, whenever there is more than one hydroxyl or OH group on a single carbon, then it is unstable. So we have to eliminate H2O from here to get this CHO aldehyde and this. After this, you are going to treat this with H plus, then this will be directly converted into OH. So this is how you will get salicylaldehyde. The most important point is this: the carbon is the intermediate. Okay. Can I change the slide?
Yes, sir.
Okay, I'm gonna give you a question that is the part of this chapter, but we already covered in aromatic compound. So if you are going to react a phenol with zinc dust, what will be the product? Please do let me know. The next reaction is oxidation of phenol. So if you're going to react this with Na2Cr2O7 in the presence of H2SO4, this phenol will be oxidized into benzoquinone. This is your benzoquinone. Okay, I have got 4 answers: benzene, adrial, PD, benzene, KV, benzene. Very good. So Ashrif, if you're going to react with this zinc with a phenol, what will happen? Zinc will take oxygen with itself, and this phenol will be directly converted into benzene, and this will be your Zn. And this
Yes.
reaction is okay. This reaction is oxidation of phenol. Oxidation of phenol. So I think it's clear to all of you. Please do write it. Now the next topic is about ether.
Sir, I have one doubt, sir.
So just let me know when to change the slide, Ashrit.
Sir, the oxidation of phenol is for the second reaction, right? Like the benzoquinone or the above reaction.
Yeah.
Okay,
This oxidation of phenol.
Yeah, okay. I thought the above
This
one.
reaction is a reaction with zinc dust. You can write reaction with no. Can I
Yes.
change the slide now?
Yes, sir.
Now we are going for ether, and everyone knows that this is your ether. Always remember that when you are going to talk about boiling point, alcohol will have the most boiling point, more boiling point than ether, then hydrocarbon. HCl stand for hydrocarbon. Why it is so? In alcohol, there will be hydrogen bonding, there will be no hydrogen bonding, but polarity will be there due to the carbon-carbon difference and electronegativity difference, and this is your non-polar. So if you are going to arrange them in increasing or decreasing order of boiling point, you have to take care of this. Now go for the ether, preparation of ether, MOP, methods of preparation. We have two methods which is very easy, MOP, and the first one is from dehydration of alcohol. If you remember in this chapter, we in the chemical reaction of alcohol, we did dehydration of alcohol and get alkene. But from the same dehydration of alcohol, we will get how we will get an ether. You will see. Just focus here. If you are having an alcohol and you are going to react this with H2SO4, since H2SO4 is a dehydrating reagent, that's why I'm using this. Okay, so see what will happen. H2SO4 will generate H plus, and you know this oxygen will have lone pair which will attack on H plus, or H plus will attack on that, and this is what you will get, OH2 positive. Now again you are going to take another mole of, this is the key point in dehydration of alcohol to get an alkene. First, the temperature is little higher in dehydration of alcohol to get an alkene, and second, we get only we do this. The temperature is high, and then we don't take 2 moles of this, and in here we take 2 moles of this. So you can see the another mole I'm going to use here, RCH2, like this. Now see what will happen. This oxygen, positive charge on oxygen is very less stable, so it will take its electron. So there will be deficiency of electron on this carbon. So this again will attack here. So see, first of all, this will be eliminated in the form of H2O, and then I'm going to write this RCH2, and this oxygen you can see OH, I'm going to write, and then CH2, and then R, this part. And since oxygen donated, so it will have positive charge. Again, in order to stabilize itself, oxygen will take electron from hydrogen, and it will release the proton. And you can see this is how we get an ether. Is that clear? So it's very simple. If I'm gonna give you a question like this, just name the product. If I'm gonna give you CH3, CH2, and then OH, and you are going to treat this with H2SO4 at 440 Kelvin. To get an alkene from an alcohol, the temperature is 443 Kelvin. So please do let me know the name of the compound, since we are preparing ether here. Oh, uh, Krishna, first of all, we are preparing ether, so don't go for alkene. And MJ, it's please write the IUPAC name.
Sir, ether is at 414 Kelvin, 413 Kelvin, right?
Oh, sorry, it's my bad. 413 Kelvin, 30 degrees centigrade less, right?
Yes, sir.
Okay. Then thank you. Yeah. No, ethoxyether is not very good PD. Say its name will be first of all. I'm gonna make it clear. Thank you, KV. C2H5OH is there, and if you are going to treat this with H2SO4 at 443 Kelvin, and if you are going to treat H2SO4 at 413 Kelvin, you will be getting here C2H4, which is ethene, and you will be getting C2H5O, C2H5, which has a name. I'm going to write here CH3, CH2O, CH2, CH3, and its name is ethoxyethane. Ethoxyethane. See, this functional group is basically bridge functional group. So either side you need to decide which one is parent function, parent chain, and which one is substituent. So since both are same, so we can take alkoxy alkane. So this is ethoxy. Very good. Can I change the slide?
Yes, sir.
Yes, sir.
Okay. The next preparation is Williamson synthesis, and it's very important. Everyone is aware of SN1 and SN2, right? Williamson synthesis. See what happens here. When you are going to react an alkyl halide with a sodium alkoxide, you can write positive or negative if you want. Then what will happen? You know, this will have positive charge, this has already negative charge, this has negative, and this has positive. So this will directly come to here, and you can see ROR will be formed, and NaX will be the byproduct. Simple. It's very simple. But what you need to take care is that this reaction proceed through SN2 mechanism. This reaction proceed through SN2 mechanism. That means the alkyl halide Rx we are talking about. So it will, the Rx, that means alkyl halide, should be 1 degree or 2 degree. It will not go for 3 degree, because for 3 degree SN2 reaction is very slow because of the steric hindrance. So I'm gonna write a point here. Formation of ether is nucleophilic bimolecular reaction. That means SN2, I'm going to write it directly, nucleophilic bimolecular reaction. And this method is suitable only for the preparation of primary alkyl halide, primary alkyl group. If you are going to take tertiary alkyl group, if you are going to take tertiary alkyl group along this side, then you know what will happen. Elimination will compete over substitution, and there will be formation of alkene. Always keep this in mind. This is your alkyl part, and this is your alkoxide part. So if this part will be tertiary, then elimination will compete over substitution, and alkene will be the major product or main product. It should be less steric hindered. Is that clear? So for better yield, I'm gonna write for better yield, Rx plus Ro negative, that means Na is also there. You can write Na plus if you want. Then you will be getting ROR. And this R should be 1 degree. That's R should be 1 degree. But if you are going to take 3 degree tertiary, if you are going to take 3 degree or tertiary and react this with CH3O negative, you know what will happen? There will be elimination. There will be elimination. And how the elimination will take place? It's very simple. You can see X will be eliminated from here and hydrogen from any of the carbon, and you will be getting CH3C, double bond CH2 and CH3. This alkoxide can be primary, secondary, tertiary, but this should be 1 degree. It shouldn't be 3 degree. Is that clear? Here it is 3 degree R. This is very important. Is that clear, everyone?
Yes, sir.
Yes, sir.
Okay. Oh, wait a minute. Okay, C2C3. Now the next is electrophilic substitution reaction. And this electrophilic substitution reaction is for ether. Can anyone tell me? And I think you can do this reaction. I'm going to give you directly in a single step. We are going to do the electrophilic substitution reaction of this, which has a common name, that is anisole. Can anyone tell me its IUPAC name? Methoxybenzene. You can write methoxybenzene. Okay, I'm gonna give you the question directly. We are going to cover. Wait a minute. Mhm. Wait a minute. Okay, this is benzene. This is benzene. And I'm going to write OCH3, that means it is anisole. So I'm going to give you the first question as this. If you're going to treat this with Br2 in the presence of FeCl3, what will be the product? And then if you are going to treat this with Rx in the presence of anhydride AlCl3, anhydride AlCl3, and if you're going to treat this with Rc double bond O Cl in the presence of AlCl3, anhydride AlCl3, and if you are going to treat this with HNO3 in the presence of H2SO. I think everyone can do this. I'm waiting. Okay, got it. Everyone understood the reaction. Since it is electrophilic substitution reaction, you know that when X2 is gonna treat with FeCl3, or you can take X2 plus Lewis acid, this will be generating an electrophile that is Br plus, and this will be X plus, and you know that OCH. Oh, wait a minute, please. Okay, so this is the screen visible to all of you?
Yes, sir.
Yes, sir.
So this, you know that this will be electrophilic substitution reaction, and this is plus M effect, ortho and para. So the product is very good. The product will be like this. This is your ortho, bromoanisole, and then para bromo anisole. Again, if you are going to this, you know that this there will be generation of an electrophile that is NO2 plus, which has a name nitronium, and this NO2 will be attacking. This NO2 will be attacking at two positions. This is your CH3, so there will be NO2, and then there will be at para, and this is your para. Para is more stable. Then if you are going for this, you know. Let me know when you are able to see this screen.
Can see, sir.
Adriel, are you able to see this screen? Okay. So this is your Friedel-Crafts alkylation. As you can see, RX alkyl halide in the presence of anhydride AlCl3. So there will be positive. So R will be added at ortho, and R will be added at para. And this is your Friedel-Crafts acylation. RC double bond O. You can see this is OCH3. So this will be added like this at ortho, and then at para. So I think you are aware of this electrophilic substitution reaction very well, right? Yes or no?
Yes, sir.
Yes.
Can we go for the next? So today we are going to do PYQs of alcohols. Wait a minute, please. So this chapter is completed, and I'm gonna give you question of previous years, and then we can continue PYQs. See. In the first step, you are going to treat this with PBr3, and in the second step, you are going to treat this with alcoholic KOH. You need to tell me the major product. Question from 2019. Okay. So see, if you want to, Hmm. Wait a minute, please. See, do you know when alcohol react with px3? If you remember, it will the major product is px. Sorry, rx. Yes or no, Adrian? This is the preparation of alkyl halide from an alcohol. Yes or no?
Yes, sir.
Krishna,
Yes, sir.
Ashrik, Marita, Priya.
Yes, sir.
Yes. Okay. So are you aware of this? Okay. This will be converted in quarks. Marita, actually, if you have written cyclohexane in at the end, either you just need to put the answer, okay? But the name is wrong. And if you have heard of this, CHBr is here, or you can do anything. Let me explain this again. See, this PBr3 or PX3, PCl3 react with alcoholic part, and you will be getting this, and you will be getting this. Is that clear? At the first place, and in the second step, when you are going to use, wait a minute, why it happens? And in the second step, you are going to use alcoholic KOH, that means beta elimination. If you remember, this is your beta and this is your beta. That means two products will be there. Bromine from here and hydrogen from here can be extracted, eliminated, and hydrogen from here. So if I'm gonna write this product, you can see, if you are going to remove this hydrogen and bromine, double bond will be here and the rest part will be as it is. But if you are going to remove hydrogen from here, then the product will be, double bond will be here and double bond is here, like this. If you remember beta elimination in the presence of alcoholic KOH, beta elimination is you are going to remove beta hydrogen and alpha halo. Okay, so this will be the major product only because this pi sigma pi, this is in resonance, so it is more stabilized than this. This is not in conjugation, pi sigma sigma pi. So this will be the major product. Is that clear, everyone?
Yes, sir.
Okay, can I change the slide?
Sir, what will be the IUPAC in here?
IUPAC name, you can take it like this: 1, 2, 3, 4, 5, 6. Cyclohex 2 in 1 on. Are you getting my point? Krishna, Marita, you had written hexane 2 in on.
Yes, sir.
So if you wrote in at the end of the alkyl group, that means it is totally saturated. So you have to be careful. Krishna, have you got it? Cyclohex
Yes, sir.
in 1 on. The next reactions are very easy if you remember the reagents work, what actually it does. And if you want to, if you try to remember the reagents, what they do and all, it will not be beneficial at all. You will be end up with confusion and all. You just need to do a lot of practice with the questions, then you can do that easily. The next reaction is very easy. This is also has been asked in the in 2019. How many products are there? It's from. Can anyone tell me which functional group is present in this compound?
Ester, sir.
Yeah, ester. It will reduce ester only, and only ester is there. Very good, Adrian. Ashrif, very good. So see what will happen. If you remember in the previous class, I had given you this reaction. Reduction of preparation of alcohol from reduction of ester and carboxylic acid, if you remember. Very good. Who is this? KV. MJ, have you got it? If you are going to use lithium
Yes, sir.
aluminum hydride. Very good. CR7. Hamza. You need to, this is a reducing agent, a strong reducing agent. See how the reduction will take place. First, it will break from here. Hydrogen will be added here and hydrogen will be added here. Then the carbon oxygen bond will be broken. Hydrogen will be added here. Hydrogen will be added here. Lithium aluminum hydride cannot reduce alkene. So see, I'm gonna write CH3, CH, double bond CH, and then you can see CH. That means CH2 and OH is there. So the name of the compound is 1, 2, 3, 4. That is due to 2 in 1 all. And the next compound is CH3OH. That is methane. Okay. Can we move to the next part? Next question. This question also has been asked in 2019. Okay, there is a question from 2019. And that is, okay, wait a minute. Okay, let me give you this question and we will talk about it. CH3, CH2, and then C, and then pH, and then OH, and then comes here, CH. Question, please do write the question. Cannot be prepared. This type of question generally takes time. And in examination hall, we don't have too much time, so we need to act smartly. Please do let me know the answer. That's good, KV. How did you get it? What is the very good PD? How you got the answer so early? Very good, MJ. MJ, any explanation for the question? Did you write all the question?
Yes, sir, I wrote the question.
No, not the question. Did you solve it like you did react this?
No, sir, I started with the last step, so I got the answer.
See, this question, if you are going to do it by mechanism, the way I told you, you have to do the reaction, all the reaction, and then you will get it. But there is another thing that I told you in the class, that HCHO, that is formaldehyde and methanol. If it is going to react with RMGX, R can be anything like pH, it can be pH, but the phenyl, ethyl, propyl, butyl, anything, you will be getting 1 degree alcohol. You will be getting 1 degree alcohol. If you are going to react methanol with Grignard reagent, you will be getting 1 degree alcohol. So focus on your degree of the alcohol. What is the degree of alcohol here? 3 degree. And I also told you that when you are going to react any aldehyde except methanol with Grignard reagent, you will be getting 2 degree alcohol. And I also told you that when you are going to react any ketone with any this RMGX, you will be getting 3 degree alcohol. So if this is your 3 degree alcohol, in the first you can see this is your ketone. If ketone is there, that means it will definitely give you 3 degree alcohol. This is also your ketone. It will also definitely give you 3 degree alcohol. This will also give you 3 degree alcohol, but this will give you 1 degree alcohol. That confirms us that this is the answer. But if all the option will be ketonic, then we have to do the reaction. It is understood. Adriel. Adriel, I'm gonna show you one reaction if you don't remember how the reaction took place. So this is your CH3. A I'm gonna take, and this is your C double bond O, and this is your CH3, and then comes your pH MgX. So first, what you need to do, Adriel, is this will go like this: negative, positive, negative, positive. So this will be attacking here, and you will be getting CH3, CH2. And then CO negative, and here it will be pH, and then comes your Mg plus here and X, and with the C this there was CH. And after this you are going to do the hydrolysis, H plus OH minus, and then this H plus will be going here, and this will be your CH3 CH2, and then CPH, and then again OH, and then CH. So you can think like this. It is same. And you can do the rest reaction with all these three, you will be getting the different answer. Okay. Is that clear? Can I
Yes,
change
sir.
the slide? Okay.
Yes, sir.
Okay. I'm gonna give you a question. From 2022, 28th July evening shift. That is sent by Marita. First, you need to react this with H plus in the presence of heat. H plus in the presence of heat. And then the second step, you are going to react this with HBr. Okay. So I'm going to explain it. Please be focused here. First of all, you know that this H plus, there is a lone pair. So this will be attacking here. And what we will get, the rest part will be as it is. The rest part will be as it is. And this will be OH2 plus, right? Yes or no? This will be OH2 plus. Now what will happen? 1, 2, 3, 4, 5. There will be hydride shift. You can see this is 1, 2, 3, 4, 5. So this will be attacking at this position. Wait a minute. Wait a minute. Already I told you positive charge on oxygen is very less stable. So this will take electron from carbon. So there will be deficiency or carbocation will be formed. So this will be attacking on this carbon. And see what we will get. We will get a 5-membered cyclic ring or 5-membered ring. You can see 1, 2, 3, 4, 5. So I'm going to write it like this: 1, 2, 3, 4, 5. And I'm going to write from here 1, 2, 3, 4, 5. And at the first carbon, there is 2 methyl groups. So I'm going to write it like this. And at the 5th carbon, you can see since this bond is broken, so it will be like this. You can see a single bond that is like this, and the positive charge comes here. Basically, hydride shifting takes place and positive charge now comes here, negative. So it will be attacking here and you will be getting this. So why this rearrangement took place? You need to see the basically options, and according to that, you will get your answer. So this is a question from 2022. Marita, the next question that you have sent, can you tell me the option? Because I think it's aldol.
Just a minute, sir.
See, this is your, you need to tell me, either you can send it in chat box, because if you are going to send them, they will take time. Please do write this reaction. This was the reaction. Does any other students practicing from PYQs previous years? Krishna, Ashrit?
Yes, sir.
Okay. Marita, are you there? Okay.
Yes, sir, just a minute.
Okay. I'm gonna give you another question. I'm also gonna give you option as well. And more than one correct can be. One or more than one correct. One or more than one correct. Very good, PD. Very good, KV. Marita, did you apply the aldol in this reaction? Yes or no?
No, sir.
So you are going to apply aldol on this reaction. You know what is aldol? Aldol condensation.
Yes, sir.
Yes or no? Everyone is aware of aldol condensation. So you are going to apply in this. Okay. Count the hydrogen and then make a nucleophile, make an electrophile, and then react it. Okay. In the coming chapter, that is carbonyl compound, we will discuss about it. The next question I'm going to give you. Wait a minute. Everyone told me the. So can you see the option? The option D and A, are you talking about, or the picture of the options? Yeah, I saw that.
Sir, the
Four options
picture.
you are saying.
Yes.
Okay, I downloaded it. And then I decided go for aldol. Okay.
Okay, sir.
Now I'm gonna give you a question. Arrange in increasing order of boiling points. In the first one, 1,2 dihydroxy benzene. This is your first one. The second one is 1,3 dihydroxy benzene. The third one is 1,4 dihydroxy benzene. The fourth one is hydroxy benzene. You are going to do it. Very good. Have you done this question before? Marita?
No, sir.
Okay. Three is the highest. Then 2, 1, 4. Very good. See, you just need to draw the structure in mind or here you can draw it. And it will be, the first one is like this, 1,2 dihydroxybenzene. And the second one is 1,3 dihydroxybenzene. And the third one is 1,4 dihydroxybenzene. So this will be the most, and then comes the 1,3, and then comes this, and then this. Fourth will be okay. Narrator, don't worry. I'm gonna give you another question, and I'll be setting a paper for the students which are facing problem in reactions. I'm gonna give you a question that is very easy. Wait a minute. C3H6. If you are going to treat this H in the presence of H plus or H2O, then you will be getting A. And if you are going to treat this with KIO in the presence of dilute KOH, then you will be getting B plus C. You need to tell me B and C. Please do. I think I had given this question before, right?
Yes, sir.
Okay, please do this, then I'll give you another question. Another question I'm going to give you is, see, this is your what? Alkene, you are going to react this with acid in the presence of water. Acid in the presence of water. So you will be getting alcohol. So this will be your CH3CH double bond CH2, and you are going to react this with reagent. Then there will be formation of a secondary alcohol. Secondary alcohol. And if you are going to treat this with this, you will be getting, basically this will be an oxidizing agent that will give you carboxylic acid, but here so metal is there, so you will be getting carboxylic acid salt, O negative, K positive, along with iodoform. This is your iodoform. So this will be your B and this will be your C. Please do this reaction. This is also from PYQ and this question is from 2021. Should I give you the option as well? This is your option A. Option B. Option C. Option D. Wait a minute, please. Let me correct it. Very good, MJ. Any answer? No KV, not B. Elimination will not take place. Rx, if it is 1 degree, substitution will be there. And this is your 1 degree. What will happen? This Br will leave the group and this negative will attack here. So what will be the product that you will get? CH2OCH3. That means the answer is D. Is that clear?
Yes, sir.
Alkene will
Yes, sir.
be formed when alkyl halide will be 3 degree. I just told you in this class. Can I change the slide? Is there any doubt in this? This is alkyl halide, so it will go out, and this O negative will attack on this because bromine took electron from carbon, so there will be positive, and this will be satisfied by this negative, and in this way CH2OCH3 will be formed. So this will be the product. Krishna.
Yes, sir. Understood.
Okay. The next question I'm going to give you is this. This is your chlorocyclohexane, which is reacting with magnesium in the presence of dry ether, and you are getting A, and then you are going to treat this with ethanol, and you are getting P. Major product you need to tell me. And option A is cyclopentane. Option B is ethoxycyclopentane. Option C is ethyl cyclopentane. Option D is cyclopentene. Any answer? MJC. Okay, basically MJ here cyclopentane will form because acidic hydrogen is there. Acidic hydrogen is there, so it will neutralize. You have to take care of it first. This is chlorocyclopentane. If magnesium is going to react with this in the presence of dry ether, then there will be formation of Grignard reagent. And if you are going to react this with C2H5OH, you know this alcohol is acidic. So this will neutralize the reaction in the presence of H plus, and it will form alkane and water. The rest part is byproduct. So the answer will be this. Generally, a student does it because there is positive and there is negative, and then negative and positive will go. You can see this positive, and this will go like this here, and it will form alkane. Is that clear? Please hold on. Is that clear, everyone?
Yes, sir.
Okay. So this is it for today. And Marita and everyone, I will make some questions on reactions and we will discuss on that. And I will suggest you people to please do revise the aldehyde and ketones. You know the basic reactions, and in the next class, we will do the reaction only. And if anyone have any doubt in a particular topic, just let me know that before the class. Like you should just message the topic to the Learnivio's coordinator, and then they will forward it to me, and then we will discuss that first and then go with the reactions directly.